Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to see another type of milling operations which are slot, keyway, end, and how the milling operations are provided and how they are performed we are going to see in this video. So I'll talk about slot milling process. In this diagram you can see a slot is being produced on your plane. They are generally used to produce any kind of slot like T slot, I slot. So your cutter is inserted from one side of your object like your plane. It moves in the direction of giving the shape, like giving a slot to the object, and the final topic is done. So in this diagram you can see that there is a slot milling cutter which has done slotting at the plane, and it is also a vertical type of milling cutter. So keyway milling are generally face or kind of horizontal milling process. So in this diagram you can see that there is a keyway produced. Like if you are using a shaft and you need to join it with another shaft, there should be a key slot which is to be produced and which is produced by keyway milling process. And this is one more type of milling cutter which is end milling cutter, and they are used to provide keys, slots, grooved but at the end side. So they are a horizontal cutter and used to do end milling. Thank you for watching this video. Stay tuned with Ekeeda and do subscribe our channel Ekeeda.
We will produce such T slots. Here are the standard dimensions according to German standard DIN 508 for T-nuts. You don't have to stick to it slavishly. T-slots are located in machine tables of milling and drilling machines, but also sometimes in cross slides of lathes and are used for fastening workpieces, machine vices, dividing heads with T-nuts M6, M8, M10, M12, and M16. A block 140 by 60 by 30 mm of mild steel. A solid carbide end mill 12 mm is inserted into a collet chuck. Let's start with the first T-slot for M10 T-nuts. First a vertical slot 12 mm wide and about 17 mm deep. Then a cross groove with a special T-slot cutter with hard metal inserts, groove width 17 mm. To be safe, we proceed with two cuts. The first is 10 mm deep, the second then 7 mm. Because of the video film, cooling lubricants are forbidden here. Moreover, this means usually a huge mess. So that the chips do not choke the groove, constant suction by a hoover is not bad. This prevents the cutter from breaking off. This T-slot cutter with carbide inserts is now used. This carbide T-slot cutter was first used with a 16mm ER25 collet. The torque could not be transmitted safely, so the milling cutter was then placed in a Weldon chuck. Please do not bother me with comments like everything should go faster, more speed. I know that too. Firstly, this makes it easier to watch, and secondly I choose the cutting speed and feed so that the machine runs reasonably smoothly. This is a 16 mm Weldon chuck. This is a 12 mm Weldon chuck. My milling machine has a 1.5 kilowatt synchronous motor. In addition, I have installed a German Wittenstein planetary gear with 1:3 ratio, see our video 140. In this video another gear brand was mounted. This combination of powerful electric motor along with a planetary gear already has a lot of torque, and Weldon chucks transmit much higher torques than Collet chucks. Now the second T-slot, this time we go to full depth 16.5 mm with the end mill 12 mm, and we make the transverse groove with an high-speed steel Woodruff keyway cutter 19.5 by 6 mm. It is not in compliance with the standards, but who cares? It works and that counts. An inexpensive set of Woodruff keyway cutters made of high-speed steel.